Hello friends, today we can discuss this problem from LeetCode, challenge problem 12, problem name last stone weight. In this question you are given a collection of stones and each stone has a positive integer weight. Now you have to take out the two heaviest stones and smash them together. Okay. Now suppose the two stones have weight such that one is greater than the other. We have to take out the maximum stones, and if the both of the stones maximum weight is equal, then both of the stones are destroyed. Else if one stone is greater than the other, then the smallest stone is destroyed and the stone with the new weight y minus x is inserted back in the list. And you have to do this process again and again till only one stone is left or no stone is left, and you have to find out the weight of the stone or return 0 if there are no stones left. Let's see this with an example. As you can see in this question, you have to first find out the maximum two stones, which is 7 and 8. If we smash them, then the smaller one, the 7 one, will get destroyed, and the remaining stone weight is equal to 1, and it is inserted back in the list. So the new list is equal to 2, 4, because 7 and 8 are removed, then 1 and 1, and 1 is originally in the list. Then we take out the maximum two stones, which is 4 and 2. We smash them, so it becomes 2. Then we take out again the maximum 2, which is 2 and 1. Then the max, when we smash them, 1 is remained because we destroyed the smaller one, and the bigger one is just reduced by the amount of the smaller weight. Then when we take out again the maximum two stones, which is 2, 1 and 1, and now only one stone is left, so we cannot destroy it with the other stone, so the maximum weight which is left is 1. But let's assume there is 2, 2, 4, 4. So we take out the two maximum one, it gets destroyed. Now the remaining list is 2 and 2. Now we take out 2 and 2, and both of them again get destroyed. So the list becomes 0. So when there is no element in the list, we have to return 0. So for finding out the maximum element in the list, we can use a data structure called priority queue, and that's what we're going to do in this question. So there's an STL for priority queue, and we have to make a priority queue of int. Let's name it pq. And for storing or inserting these element of stones, you can directly insert it using this syntax, comma end stones. Then now the priority queue is filled. Now we have to do this process while the priority queue size is greater than 1. What we have to do is we have to pop out the first element, the top element of the priority queue, and we have to first see what is the top element and then pop out. Then you have to do again for the second element, what is the top element, and you have to pop out. Okay. Now what we have to do is, because A is greater than B, obviously because we popped out A before B, and priority queue stores the maximum element first and then the smallest element. So this may happen at A equal to B, because if the list contains 2 to 4, 4, then the first popped element is 4, the second popped element will also be 4. But we only matters if the size of A is greater than B. Then we have to insert back. Okay. So if the size of A is greater than B, then what we have to do is we have to insert push again. What we have to push again? Because A is greater than B, A minus B. And if A is equal to B, we have actually popped out that element, so we don't have to do anything. Okay. So what we have to return is, if we have to check the size of PQ. If the size of PQ is equal to 0, it means like there is no element in it. We have to return 0. Else, if the size is greater than 0, we have to return PQ dot top, the top element of the variety. And yep, that's the point. Answer is giving that. Let's submit it. Yeah, it's accepted. I hope you understand the logic. If you have any doubts, please mention down, and I'll see you in the next one.